Hello students, this is 10th class new maths textbook, the first chapter real numbers, and this is exercise 1.2 and this is part 2 video. In this video, we will learn the solutions of first, second and third bit of question number 3. This is the chapter real numbers and this is exercise 1.2 and here is the question number 3. Prove that 1 by root 2 is an irrational number. I shall repeat. Third question, first bit, prove that 1 by root 2 is an irrational number. In order to prove this type of questions, we already adapted an indirect method of proof. We already discussed what is indirect method, and here this question is also can be solved using the same method, indirect method. In indirect proof, let us assume that the given question is false. Here what is the given question? 1 by root 2 is an irrational number and this is false. Okay. If 1 by root 2 is irrational number is false, then 1 by root 2 is not an irrational number. If it is not an irrational number, then 1 by root 2 is a rational number. 1 by root 2 is, if it is not an irrational number, then it should be a rational number. If it is a rational number, you can write it in the form of a by b, where a and b are integers and b not equal to 0. Of course, both a and b are co-primes. Here 1 by root 2 is, since it is a rational number, you can write it in the form of a fraction. That is 1 by root 2 is equal to a by b, where a and b are integers and b not equal to 0. This is the condition. Okay. Now since 1 by root 2 is a by b, you can find the reciprocal of this LHS and RHS. That is root 2 by 1 or root 2 is equal to b by a. You see, you can observe that root 2 is an irrational number and b by a is a rational number. But of course, we know that an irrational number cannot be equal to a rational number. Once it is an irrational number, it should not be a rational number. If it is a rational number, then it should not be an irrational number. Therefore, both may not be equal. Both should not be equal. An irrational number cannot be equal to a rational number. That is, our assumption is false. What is our assumption? 1 by root 2 is not an irrational number is false. Therefore, 1 by root 2 is an irrational number. Is it clear? Good. Let us solve question number 3, second bit. Chapter real numbers, exercise 1.2, question number 3 and second bit. Prove that 7 root 5 is an irrational number. Prove that 7 root 5 is an irrational number. Here in indirect proof, again we will start with indirect proof. In indirect proof, let us assume that the given question is false. That is 7 root 2 is not an irrational number. 7 root 5 is not an irrational number. If it is not an irrational number, then it should be a rational number. 7 root 5 is a rational number. If 7 root 5 is a rational number, then you can write it in the form of a by b. 7 root 5 is equal to a by b, where a and b are integers and b not equal to 0. Now, if you observe this, 7 into root 5, 7 root 5 means 7 into root 5 is equal to a by b. Here this 7 may multiply root 5. If you take it to other side, you should divide or you should go to the denominator. That is root 5 is equal to a by 7b. Root 5 is equal to a by 7b. Here again, if you observe this equality, root 5 is an irrational number and a by b is a rational number and a by 7b is also a rational number. Therefore, an irrational number cannot be equal to a rational number and our assumption is false. What is our assumption? 7 root 5 is not an irrational number is false. Therefore, 7 root 5 is an irrational number. Is it clear? Good. Now, let us go to the third bit of the third question. The chapter real numbers and exercise 1.2, question number 3, third bit. Dear students, here we have to prove that 6 plus root 2 is an irrational number. How can you prove it? What type of method we will adopt now? Okay, good students. We have to use indirect proof method. In indirect proof, how can we assume this? Yes, we have to assume that 6 plus root 2 is not an irrational number. Okay. In indirect proof, let us assume that 6 plus root 2 is not an irrational number. If it is not an irrational number, then what it should be? Yes, it should be a rational number. That is, 6 plus root 2 is a rational number. If it is a rational number, how can you write it? Okay, if it is a rational number, you can write it in the form of a by b. 6 plus root 2 is a by b. What is the condition for a and b? Yes, a and b are integers, and b, the denominator should not be 0, b not equal to 0. And what is the one more condition? Yes, a and b should be co-primes. There should not be any common factor for both a and b. Now if you observe the LHS, you can find a rational number and you can find an irrational number. Now what to do now? Yes, we have to take this 6 to the other side of equality. That is, root 2 is equal to a by b plus 6 other side minus 6. Now you can find root 2 at LHS. Root 2 is an irrational number, we already proved it. And a by b is a rational number and 6 is a rational number. Then what is the difference between rational and rational? If you subtract a rational number from another rational number, you will get a rational number only. So we arrived at a wrong conclusion. That is, one root 2, an irrational number is equal to a rational number. An irrational number is equal to a rational number, but it should not be possible. It is not at all possible. Therefore, an irrational number cannot be equal to a rational number. Why we have arrived at this place? Because we assumed a wrong assumption. We took a wrong assumption. That is, 6 plus root 2 is not an irrational number, is false. Our assumption is false. Since this is false, then 6 plus root 2 should be an irrational number. By this, we solved all the problems of the chapter real numbers, of all the 2 exercises of the chapter real numbers, and you can practice them once or twice, and there are some more example problems are also there. You may practice them one by one. Thank you and all the best.